So, hi everyone. I hope everyone can understand me here. So, I will give the talk in English because I think it's more convenient for many of you, and most of the Germans they speak English. So, yeah, first of all, I'm really glad to see so many interesting people, interested people who want to know something about how we deal with AI at Frankfurt Airport, which is not too far away from here. And in particular, I want to talk about an application that we developed in-house at our airport in the baggage handling system. But first of all, let me do some advertisement why it's actually what makes it really nice to work at the airport. If you want to work with AI systems, we established an AI community at the airport at Frankfurt. It's called ECI. So this is some more German based, but basically it's called Excellence Cluster for Artificial Intelligence. And we provide a lot of, so besides that we do some consulting, we also really try to share our knowledge among the airport. And we are also responsible to develop the AI solution, to maintain it. So we develop the model, but we also bring it into production. So in many different contexts, if it's about terminal operations or operations on the apron, we cover a huge amount of topics here. Okay, so let's dive into the application that we developed at Frankfurt Airport. It's called LURAI, Luggage Recognition AI, and it's about a use case that was presented by the ground handling department to us. So the ground handling department is responsible for the baggage handling system. At Frankfurt Airport, we have more than 80 kilometers of conveyor belt and rail system within the conveyor belt infrastructure. A baggage handling infrastructure, and yeah, there are many use cases which actually which already were tackled, but which still have to be resolved. So it's all about, I mean, a huge amount of applications just arises from or can be solved by using computer vision. And just here, I give you just a short list, among others, which are quite important to solve in the infrastructure of the conveyor belt system. For example, tracking luggages. So in many, or not in many, but in some cases, it can be that tracking of luggages gets lost. So we use computer vision, camera technology, for example, to track those luggages, to find them, or to collect features of them. For example, to know the color of a luggage, or whether it's hard shell or soft shell, can be a really important feature for the operational stuff. For example, if they want to find a particular piece of luggage, it's really helpful. Yeah, we are searching for red baggage, and right now, yeah, we don't have this particular information. Then what else? What's really important topic is the point number 4, loading support on the carousel. So if we for example, consider the journey of a piece of luggage for a transfer flight. So staff puts the piece of luggage on the conveyor belt, then it goes on its journey through the baggage handling system, and at some point it gets out of the system, and staff again takes the piece of luggage and puts it in a container. But this is quite an exhausting process, or it's actually pretty hard for the operational staff, because first they have to scan the piece of luggage, and on the other hand they carry the piece of luggage. And it would be really nice to get rid of this scanner, so they can use both hands to just put the piece of luggage in the container. So that's where we also want to establish a tracking system on the carousel to track the luggages, and to give a visual signal, for example, to say, okay, you have to put the piece of luggage in the left container behind you. Okay, but for this particular problem that we tackled, actually, it's all about tracking error. So I told you it's really important that we are able to track luggages. So we know if we take a picture of a suitcase, we want to know what kind of suitcase is it. I mean, what's the destination? what's the passenger, what are the relevant information for this piece of luggage. So we know how to where this particular piece of luggage has to go in the conveyor belt system. And the problem here is, the problem is that the tracking in some occasions it fails. So we don't know if we have a piece of luggage somewhere, operational staff sees it, or some other system detects a piece of luggage in the baggage handling system, but we actually don't know what kind of luggage is this. And in those cases, operational staff has to manually rescan it. And you can imagine, I got some numbers here. There's a huge range of those tracking errors. It can be from 0.1% until 20%, depending on the day, depending on the time of the day. For example, in the morning we have several peaks, and it can be really hard then. And those tracking errors can occur, and then the operational staff has to manually recode all those luggages. And this is time intensive. So there's a high risk that luggages miss their flights. So the ground handling system wanted to solve this problem, and the approach was to use camera technology in combination with AI. Here, again, we have some kind of picture. So what is I'm a mathematician. I try to break this down to a really simple problem. So we have two locations, A and B, and we have a piece of luggage which we can see at location A, and we want to recognize it at location B. This is a really simple question. And now the question, the key is how can we solve this? And in our particular case, we use we had a proof of concept where we had 3 cameras at the first location and 2 cameras at the second location, and we tried to recognize the piece of luggage. Because what are the important information here? So if we scan the baggage at location 1, there's a scanner gate which scans the barcode of the piece of luggage, so we know all the information. But then there's some journey on the conveyor belt, and on this journey a tracking error can occur where we lose the information. So if we have a look again at location 2, we don't know the information anymore. But just imagine we take a picture at location 2, we can find the matching image at location 1 where we already know the information. Then we can reestablish the matching again, and that's what we did. And this was quite pioneering work at the airport, at our airport. We had to establish like a computer vision pipeline, which was quite cumbersome at some point. For example, to get all the image data, we trained an AI model on 80,000 images, and just to detect a piece of luggage. So because the luggage is not always a nice, if you see it from above, it's not always a nice rectangle. It can be everything. It can be a bag, or it can be covered in foil or something. So yeah, it's of course there are some pre-trained models already on the market, but you have to retrain them. You have to modify them so you can cover all the all the luggages that there are available outside. So and then I told you we retrained the model, so it's all about labeling. I'm pretty sure some people of you work in the AI business, and they know that labeling is like one of the most crucial steps. Bad labeling leads to really bad results. So yeah, we invest some time also how to think about, for example, do we label the bag tag? Because if you have a piece of luggage like this, the bag tag can be somewhere here. And if you label the bag tag and you say, there, this is something which belongs to the luggage, then it's a problem because you label a lot of background. So those are some questions that you have to consider if you do this. Okay, maybe then we can talk more about the structure. So we use edge device technology to process the video streams that we have at both locations, and to also apply the AI models. And then we have so as I said, we have cameras at location 1 and 2, so we have different camera streams. We also, maybe this is also nice to see here, we have can you see this? Oh, I will just show like this. This one is a tray or a container where the luggage gets loaded in. And we also use camera technology to read this code that you can see there, all those white squares. It's a Hamming code, and we also use camera. We have a camera and some software behind it to read out this code. So we have 3 different camera streams in total, and some AI models that work together in a pipeline. And what kind of models do we have? So first, I said we first have to detect the piece of luggage, right? That's the first step, which is called we call it detector or detection. This is really, I mean, basic stuff. I mean, it's done everywhere, counting cars or what else, counting people, and we just detect piece of luggages, and the result is something like this. I'm pretty sure who among you who already worked with, for example, TensorFlow object detection API, they know what the output looks like if they apply an AI model to some kind of image, at computer vision model, and then if we have the detected image, the detected piece of luggage is just a small piece of the whole frame. We apply another AI model which just computes a digital fingerprint, which is nothing more than a vector which consists of some features, but most of the features we cannot interpret. Of course, it's like more than 4,000 features. It's a superposition of color, of I don't know, form or something, shape of the image, maybe. And interestingly, it also nice. You can also reuse this model, for example, to train on top a model which can detect whether it's a hard shell or soft shell. So this vector already covers a lot of features. I think I have still 1 minute, 3 minutes. Oh, perfect! It's like holiday, like really luxury. Perfect. Okay, so let me show you. Can you see this? It's okay. So this is how the live tracking works. So this is where the luggage gets automatically loaded from the conveyor belt to the tray. And you can see, I'm not sure whether you can see it, but there was like a blue rectangle around the piece of luggage. I didn't do this by hand. This was done by the AI, of course. And another video here, you can see how it looks like on the conveyor belt. So luggage comes inside. We have some detection algorithm here, and some metadata here. Yeah, and that's how we crop the detected luggage and then process it to get this or to obtain the digital fingerprint. Okay, so maybe some nice or some KPIs that we collected or that we had to fulfill in order to for the application to be satisfying for the ground handling department. So just in this year, we already corrected more than 500,000 pieces of luggage. So yeah, I mean, of course, if you, it's not just about the number; it's about the concentration over the day. So as I told you, 20%, for example, of tracking errors in the morning can be really hard for the operational staff to handle. But still, for me, it's quite impressive. Already 500,000, and we only use 6 transfer points. So it's just about transfer luggage so far. But we plan on a further rollout. We have 5. We already have 5 more transfer points, which we equipped with this, and it's running now for more than 2 years. We can correct 92% of the tracking errors automatically, and maybe another technical, really nice technical feature. It just takes 0.3 seconds for the whole pipeline to detect the piece of luggage and to compute the fingerprint, because this is really crucial, because we don't have much time between 2 pieces of luggage. So this is a streaming application, and we just have like 2 seconds between two succeeding events. Okay, so it's done. No, I don't have time anymore. Okay. So then, thank you very much, and I hope and just enjoy the fair.